All right, this is another big problem, but if we break it up into expanded form to help make it easier, it's not too bad. So let's do it. All right, so we have m cubed n to the 6, and then m to the 6 squared times n on the bottom. So note when we have something that looks like this, okay, if I have different bases, this is an m, this is an n, there's nothing I can do on the top. The top is as simplified as it goes. So m cubed n to the 6. On the bottom, though, I've got something weird going on here. I have a 6th squared. So remember, if we expand that into expanded form, m to the 6th times m to the 6 would be m to the 6 squared. We have 2 m to the 6's. And if we write that out even more, we have m times m times m times m a whole bunch of times. So we have 6 m's here and 6 m's here for a grand total of 12 m's. So m to the 12 and n. Remember, anytime there's no exponent, there's always that invisible exponent that says we're working with n to the first, so something to the first power. So that's how we simplify just this part, the m to the 6 squared, but we still need to deal with this. I know I'm not done yet because I still have an m. I have more than one m in my problem, and I have more than one n, so I have to take it further. So if we further write that in expanded form, do that here, we have 3 m's on top, and then 6 n's. On the bottom, I have 12 m's. And then 1 n. Okay. So then we can start crossing off stuff that we see on top and bottom. So I have an m and an m. I have an m on top, m on bottom. So I can cross off 3 pairs of m's. And then we look at our n's, we can start crossing those off. And since there's only 1 n on the bottom, that's all we can do. So now I'm left with, if I count them, 1, 2, 3, 4, 5 n's on top. So n to the 5th. And when I count them on the bottom, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. So m to the 9th on the bottom. And don't forget, when we're doing our rule here, if we have same base, so we have cubed and 12ths, then we can just subtract exponents. So let's do that real quick. Erase this. If I subtract the exponents, m to the 3rd minus 12, that gives me m to the negative 9. If we remember what negative exponents do, they flip our fraction, which means the m to the 9th should end up down on the bottom of the fraction. And with our n's, if we do n to the 6th minus 1, 6 minus 1 is just 5. So n to the 5th is going to stay on the top of our fraction. No reason to move that down. So remember, we can apply any rule we want as long as we're applying it correctly. So this is my answer, and I would enter it on Schoology as n shift 6 5 divided by, or the slash symbol, m shift 6 9.